In this recording, we're going to look at the derivatives of trigonometric functions. The derivative of the sine function is the cosine function. So the derivative of sine x is cosine x. The derivative of the cosine function is the negative of the sine function. So the derivative of the cosine of x is negative sine of x. Now let's use that in these two problems. First, let's differentiate y equals x squared minus sine x. So that would be y prime equals. Now the first term, x squared, is a power rule, so that would be 2 times x to the 2 minus 1, or 2x, minus the derivative of sine x is cosine x. So y prime would be 2x minus cosine x. In the second problem, y equals sine x cosine x, when we differentiate here, we will have to use the product rule since we have a product. The product rule tells us to take the first term, which is sine x, times the derivative of the second term, which is cosine x, plus cosine x, the second term, times the derivative of the first term, which is sine x, or the first function. This gives us sine x times the derivative of cosine x is negative sine x, plus cosine x times the derivative of sine x, which is also cosine x. And that gives us sine x times negative sine x is negative sine squared x, plus cosine x times cosine x is cosine squared x. So if y equals sine x cosine x, y prime is negative sine squared x plus cosine squared x. Now the other four trigonometric functions have the following derivatives. The derivative of tangent x is secant squared x. The derivative of cotangent x is negative cosecant squared x. The derivative of secant x is secant x tangent x. And the derivative of cosecant x is negative cosecant x cotangent x. Now let's use that information for this problem, and we want to find the derivative of tangent x divided by 1 plus tangent x. Now here we have a quotient, so we will be using the quotient rule. Remember, that was the one we had the mnemonic device for, and it was low, which is our denominator, 1 plus tangent x, d high, so the derivative of the numerator, which is tangent x, minus high, which is tangent x, d low, the derivative of the denominator, 1 plus tangent x, and down below the square will go. So that is all over 1 plus tangent x squared. So we'll take the derivatives in the numerator, that's 1 plus tangent x, times the derivative of tangent x is secant squared x, minus tangent x, times the derivative of 1 is 0, and the derivative of tangent is secant squared x. So the derivative of tangent x is secant squared x. Of course, that's all over 1 plus tangent squared, tangent x squared. Now, in the numerator, first let's use the distributive property. 1 times secant squared x is secant squared x, plus tangent x times secant squared x is tangent x secant squared x, minus tangent x secant squared x, and this is all over 1 plus tangent x squared. Now notice on top we have tangent x secant squared x minus tangent squared secant squared x, so those will cancel. That should have had an x right there, sorry about that. That will leave us with just secant squared x on top and 1 plus tangent x squared on bottom. So the derivative of tangent x divided by 1 plus tangent x is secant squared x divided by 1 plus tangent x squared. Now let's do another example. This question asks us to find y double prime if y equals secant x. So the second derivative if y equals secant x. In order to find the second derivative, we first have to find the first derivative. Our first derivative, the derivative of secant x is secant x tangent x. Now y double prime is the derivative of the first derivative, so the derivative of secant x tangent x. Well, that is a product rule, and the product rule tells us to take the first function, which is secant x, times the derivative of the second function, which is tangent x, plus tangent x times the derivative of the first function, which is secant x. So we have secant x times the derivative of tangent x is secant squared x plus tangent x times the derivative of tangent x, which is secant x tangent x. We'll multiply here. Secant x times secant squared x is secant cubed x plus tangent x times secant x tangent x is secant x tangent squared x. So the second derivative of secant x is secant cubed x plus secant x tangent squared x.